Good morning and welcome to my presentation for this HILTI challenge. My name is Emre Ergin and I studied architecture in RWTH Aachen in last 3 years. Now I am continuing with my master's degree in construction robotics in the same university. In this video, I will be showing and presenting my project named Handheld Tool Usage Tracking and Process Identification. I wanted to concentrate on this topic specifically because after my researches, I have seen that there is small steps to take into the future of the construction industry, and fully automated construction sites with minimum possible human inputs. After my research, I see that, as I said, this development of the technology takes small steps. And each of those small steps begins with data collection. So if we are able to collect data from the construction sites, then interpret them, then build upon them, then test them, we can create those loops and see that if they succeed, it can mean that we took a further step into the future of this industry. In my project, I will be concentrating on workflows, work processes, and operations on the construction sites. I wanted to get a better insight on work processes and operations on the construction site to be able to optimize them, to be able to make them efficient, or maybe identify different kind of problems before they are occurring, and so on. The problem that I wanted to concentrate on is based on the operation identification. So each day or each week or maybe each month, manager gives tasks to the workers, and workers go to their operation places, get their tools, and they start to make their work each day. Then at the end of the day, they return their tools, and at the end of the day, manager get a report of what has been done correctly or what was the problems, and manager sees that, okay, what was the reason of the problems, what was going wrong, and so on. But those information is given by the workers manually. So one worker or one someone from the workers gives this data and information and says that, okay, this has been done wrong, this was wrong, or we had that problem, and so on. But it's never possible to get exact data of what happened and what was the real problems that has been unseen, and so on. So my focus is to get a daily process of on the construction site, so to get a better insight. First of all, I wanted to concentrate on uh, identification of the operation. So how do we understand, or how a computer system identifies what has been done, or what is the operation that has been recorded. So I took a look into some existing technologies in the industry, in the daily work, in daily life. Then I came up with those technologies, and I want to explain them briefly. First of all, computer vision systems. They are based on cameras and image recognition techniques. Uh, the cameras record some photos, some pictures, images, or some videos. Then they start to identify some assets and some parts based on their location on the recorded image, and they make assumptions based on those images. It can some kind of machine learning system can be also integrated to make those assumptions and so on. But from my point of view, this is not a reliable way to integrate on construction site, even though there are some approaches or researches on the construction site. Because on a construction site, nothing is static. Everything is moving constantly. Some balls are moving, huge machines are moving, humans are moving, tools are moving, sometimes floors are moving. So it's it might be harder to integrate this technology on a construction site. Next step is inertial systems. They are based on some small sensors. They are integrated on different parts of human body to uh, get or combine these different joint data, movement data, acceleration data, or position data, orientation to make assumptions to identify what this human were doing. Is he moving his hand upwards, downwards, or he's turning something, and so on. Those systems are also used in daily life, for example, in fitness or training, uh, in trainings to count repetitions and so on. But the context is really the context should be known to identify those. So it's not always the same thing. And last but not least, I have seen those mechanical systems which are based on mechanical movements or measuring of mechanical analog input on some kind of joint values or human values, but they require mostly a external exoskeleton like implementation which can interfere with specific operations on the construction site for workers. So uh, most of those approaches, as I said, there are some issues that I mentioned, and uh, I wanted to actually concentrate on something else. I wanted to find something else on the construction site that's easier to track, and it's actually better to identify which operation has been done because by only tracking the human motion, it's really hard to identify what has been done exactly. So we can't say that something has been drilled, some nail has been hammered, and so on. So I wanted to concentrate on something else, which are the tools, because on a construction site, uh, almost each operation requires some specific tool, and it's easier to maybe it's easier to track those tools because each tool has its own functionality. So you can't drill a hole with a hammer, so or you can't do different things with different kind of equipment. Each tool has its own purpose. So why not track tools instead of complex human motions? And this could give us better insights. Then I wanted to make a market research. I made some market research on tool tracking concepts, and then I came up with those dominant ones. They are for example, first one is inventory based, where an image is of the tool is scanned, and the data is of who took it, when it has been taken, what has been taken, and so on, or returned. Those data can be recorded. And secondly, I had found a system where it's basically a smart cabinet. Each tool has its own place, and when a tool is taken, it's automatically detected by RFID technology of which has been taken and which not. It's more seamless than the other scanning one. But both of them are giving me data such as check-in and check-out data. So we know who take it and when it has been taken and what is it has been taken or returned, but we don't know exactly what happened between them. Maybe a tool can be taken on Tuesday and returned on Thursday, and we don't know what happened between them. Maybe it's not used at all. But this system can give us only the statistics. But I want to concentrate on data. What happened exactly? I don't want to concentrate on statistics. And last approach was actually from a research paper which uses existing sensors from a smartwatch to detect vibration and sound of a specific hand tool to identify what it is. But this was, from my point of view, what was not a great implementation on the construction site where everything is too loud and there might be some different kind of vibrations during the operations and so on. Then I wanted to have my own approach in this system instead of those check-in check-out based systems. So my goal was to track some tools, and I see that human hands are very important during in every kind of operation, not in only in construction industry. So I wanted to integrate something on the hands because each tool or each asset has at least one valid grasping valid grasping for primary handle. So each tool has a primary handle to be held to operate it with it correctly. So I wanted to concentrate on implementing something on the hand. First of all, I will be showing my vision, what I want to achieve. with this video. In this video, you'll be seeing a construction worker from his point of view, and this will help us uh, to this will help you to see what I am planning to do in this project. So this worker starts working with a tape measure on a specific time, and this tape measure is detected on the right upper corner at some specific time. As he continues using it, this tape measure is detected. Then, when he drops it, it's not detected anymore. You see on the upper side a line, the line of different kind of tools. At specific time, circular saw is detected and it's indicated by a different color. So the system starts recording it that this circular saw has been used between those times. That after he leaves it, then it gets undetected. Then there he is using a pencil, marking some spots. Then he's using a tape measure. Then he's using a drill, which is indicated by orange and so on. And after this operation is done, we see that this time process creates signature that I want to call as a signature, operation signature. You see that between a time interval, it those items has been used, and if we record this data, this can give more insight during a daily worker operations. Now I want to um, show my approach on how I did my prototype for this system. I wanted to use very cheap RFID technology and integrate it on the inside of the existing safety gloves. By using really thin copper wires, which are stitched into the inner side of the glove, and this can be used as an external antenna for RFID reader, which will be also implemented in the glove. So we could this safety glove could detect different kind of RFID stickers, which are already sticked onto the primary handle of the different tools, as you can see on the right side. So basically, this uh, safety glove would read data, would read this RFID stickers, really cheap RFID stickers on the tools, active tools, passive tools, or any tool any hand use tool. So it could seamlessly, without any input from worker, detect what is going on, what's used right now. And this data can be saved, for example, like every 10 or 15 minutes in this glove, then can be sent using LoRa to a server to be stored there and then combined at the end of each day. Now I want to show my my prototype that I had created. On the right lower corner, you will see a video of my prototype in real life, and I will be holding different kind of tools. And you see also my interface where I am recording this data and visualizing this data. First of all, here's my glove. Uh, I integrated only on the inner side of the thumb this coils, copper antenna, and it detects based on this antenna. So I am holding a drill right now, and as you can see, it's detected on a specific time. And now I am using it, I am turning it, and so on. After I leave it, it gets undetected, and this starting and ending time of this tool has been recorded under the Excel sheet where we can process this data or combine this data later. And on the bottom, you see my Gantt chart where this system is recorded simultaneously. Now I will be using different kind of tools to show that there is a different capability of tracking different tools. As you can see now, I am using a tape measure and I am operating with it, and it still detects it. For demonstration reasons, I also uh, make it read different kind of RFID text, so we see that there's uh, different approaches. As you can see, different items are detected and logged into Excel sheet as well as Gantt chart and line chart. Yeah, and that was it. Now we have the data, and what are we doing with this data? First of all, we can visualize it. So here you see a gun combination of Gantt charts where each row represents a different item, different tool, and each column represents time step in a daily work. You can see that in the morning, for example, this worker was using tape measure, table saw, and drill press. And at the afternoon, he was using like saw, bench grinder, wrench, pliers, screwdriver, and so on. So this data can be visualized to get a better overview and to identify what has been done. For example, we say that this worker was working on a roof construction, and this first space its first sequence can mean that it was cutting wood or like it was measuring wood, making some marks, then cutting it. Then he prepared for it assembly. Then he used like screwdriver to assemble it and so on. And this data can be actually combined under one line. So we get one line for each worker during the day. So and if we want to make it anonymous, we can combine it with different workers. So we don't know who did what exactly, but we know which group of workers did what during the day. So it makes it more anonymously and it doesn't interfere with human rights, especially in Europe. This is a huge problem for actually huge problem which makes sense because it's the privacy is also more important for the workers or for all human beings. So with combination of these different kind of different operation signatures from each worker, we can get team job identification or individual job identification during the day. This data can be fed into, as I said, a machine learning system where we can identify some parts of the work's operations during the day. For example, this can mean aluminum facade panel cutting, or this can mean wooden slat facade assembly, or something else can mean reinforced column construction, and so on. After some specific time that this data set is created, this system can understand what has been exactly done, what does these sequences mean, and so on. And based on this knowledge, it can rate a group of workers by their efficiency, and they can be rewarded, for example, or they can be talk with them. There might be some also psychological problems with them, and so on. And based on this data, they can be rated with efficiency, and this next for it can be some specific workers or groups can be suggested for next tasks since they are working efficient, they are working faster and correctly, and so on. So there is a validation requirement in this suggestion. Lastly, I want to really briefly mention the further development possibilities. This technology can be implemented to a really smaller form factors, for example, a ring with using nanotechnology. And I also wanted to integrate some vibration sensor because when a power tool is stuck, it vibrates for a second, and this is a strong vibration. This can be a strong vibration. So if we can also collect this data, we can say that okay, this, for example, drill was stuck for a moment, so there might be some misusage of this tool or drill bit was wrong, and so on. And I also created a prototype of this. On the right corner, you see my hand. I am holding a screwdriver, but let's say this is a power tool. And for example, when a sudden movement, when sudden shaking appears, it indicates with light. and it indicates it with red marks on the Gantt chart, and also you can see the disturbance of this line chart. So this data can also be correct connected if there was a tool misusage, and this can also be interpreted. And lastly, instead of only RFID, NFC technology, NFC stickers can also be used because those NFC stickers can be programmed, and we can get more data from tools like the current like electric flow current, or some pressure requirements, some pressure values, and so on. Yeah, thank you for attention. That was my presentation.